Your quiz tomorrow is 8 questions. You're going to have 3 types of questions. You're going to have something like from this first section where you have to move everything to one side. This is solving our non-linear inequalities. Then you're going to have a few that are solving absolute value inequalities. And then you're going to have a few that are solving absolute value equations. So we're going to go through all of these and make sure we understand what we're doing and how to answer these and all that good stuff. So if you look at number 1, number 1 says to solve and graph, write your answer in interval notation. Okay, these are non-linear inequalities. When you start off with a problem like this, thank you, we need to move, excuse me, everything where? To one side. All right, once we move everything to one side, we're good to go. This is a positive 18. When I move positive 18 to the other side, it becomes what? So x squared minus 7x minus 18 less than or equal to 0. Agreed. Now that we have everything to one side, and it's set less than or equal to, greater than or equal to, whatever, 0, you can do our little trick. This says less than or equal to. If I have less than or equal to, what kind of dots do I have? Closed. They're going to be closed. And where do I shade? In the middle. In the middle. Good. Now what we do with this, since it's a quadratic, we are going to find our boundary points. I'm going to factor. All right. What 2 numbers multiply to give me negative 18, but add to give me negative 7? Zach. X minus 9, x plus 2. Okay, are you going to tell me the same thing? Perfect. So when I solve this, I get x equals positive 9 and x equals negative 2, correct? So on our number line, we're going to have negative 2, 0, and 9. What kind of dots did you tell me are at each of those points? They're both closed. Make sure that I can tell that they're closed. I don't have to guess. And where am I going to shade? In the middle. Now, do you absolutely have to check? No, but I would. Just take a second to check, because in that rare case, and we'll see one of those rare cases in a minute, in that rare case that for some reason every number on the number line works, where your answer would be negative infinity to positive infinity, we have to make sure that this isn't that's not happening. So the first number, what's the easiest thing to pick?
0.
0. If I plug in 0 at the top, guys, into your original, what's 0 squared?
0.
Minus 7 times 0.
0.
Is 0 less than or equal to 18?
Yes.
Yes. All right, let's pick another number. What? Yes.
10.
Okay, let's pick 10. What's 10 squared? 100. Minus 7 times 10 is 70. What's 100 minus 70?
30.
Is that less than or equal to 18?
No.
Then we're good. Now, I need to write my answer in interval notation. How would I write that? Tell me, Kiara. Okay, bracket, you're fine. Bracket, negative 2, comma, bracket. Perfect. There's our answer. Questions. All right, let's look at the next one. Same kind of thing. I have a non-linear inequality. So I need to first move everything where? To one side. I'm going to take positive 5x and move it over here. So do you guys agree with me? This becomes 2x squared minus 5x minus 3 greater than 0.
Yeah.
Okay, now that everything's on one side and 0's on the other, what kind of dots do I have?
Open.
Both of them are open. And if it's greater, which way do I shade? Perfect, to the outside. Good job, guys. So now we go through and we factor. So I say a times c. Factors of negative 6 that multiply to give me negative 6, but add to give me negative 5.
Negative 6 and 1.
Negative 6 and positive 1. Agreed? Okay, x minus 6 and x plus 1, correct? Can I just leave it like that, Kiara? Why not?
You have to divide it by 2.
I have to divide both factors by 2 because my a term is not 1. So this becomes perfect. X minus 3 and 2x plus 1. Both of those set equal to 0. So when I solve this, this becomes x equals 3, and this becomes x equals negative 1/2, right? Yeah. I have 2x plus 1 equals 0. So subtract 1 from both sides. 2x equals negative 1. Divide by 2. And x equals negative 1/2. And then the other one, x minus 3 equals 0. You just add 3 to both sides. So I have a point at negative 1/2 I have 0, and I have positive 3. What kind of dots do I have at negative 1/2 and positive 3? Why are they both open? Because there's no or equal to underneath my inequality sign. And which way at the beginning did we say that we shaded? Outside. To the outsides. Now let's just check just to make sure. Make sure that you guys let me know where you're shading so I don't have any questions. What's an easy number to check?
0.
Let's try 0. When I plug 0 into my original, should 0 work? No. So plug it in. What's 0 squared?
0.
Times 2.
0.
Minus 3.
-3.
Okay. Is negative 3 greater than 5 times 0, 0? Is negative 3 greater than 0? No. So we are correct. So what is my interval notation? Reese, tell me. I read from left to right. So over here is negative infinity and over here is positive infinity. Can you help me out? Well, we start over here at what?
Oh, negative.
Negative infinity. Good. To what number?
Negative 1/2.
Perfect.
And then
Positive 3 to what? Infinity. Right?
I didn't know if it was negative.
That's okay. Negative infinity is on the left, positive infinity is on the right. And then that gap is where we put the U. It's like this one or this one. Okay? We all right? All right, scooting along. Again, this is a non-linear, right? We have a non-linear, so I need to set everything equal to 0. We have to move 12x over, and we have to move negative 4. When I move 12x over, it becomes what? Negative 12x. And when I move negative 4 over, it becomes what? Positive 4. All of this less than 0. Is everything on one side 0 on the other? Okay, so now I can look at this and say, open or close dots when I graph. Open. And it says blah, 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 blah is less than. Where do I color? In the middle. All right, guys, this is a factoring problem. This is a factoring problem. When we have 4 terms, Kiara, what do? God bless. We group. First 2 and the second 2. What can I take out of 3x cubed and minus x squared? Take out x squared, and I'm left with 3x minus 1, correct? What can I take out of negative 12x? Sorry. Yeah, negative 12x and a positive 4. That's going to leave me with 3x minus 1. What kind of 4? A negative 4. Remember, if we lead with a negative, take it out. So that changes the sign here. If I divide by negative 4, this becomes 3x minus 1. Do you guys now see the new GCF? What do they both have in common? The 3x minus 1. So that comes out in front by itself. And then what happens to my little leftovers? We put them together. They get their own parenthesis. Guys, can you factor this a little bit more? Is that the difference of perfect squares? It sure is. 3x minus 1, x plus 2, and x minus 2. So how many different points am I going to have on this graph? 3. I'm going to say 3x minus 1 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So we add 1 to both sides. 3x equals 1, divide by 3. I have a point at x equals 1/3. Here I'm at negative 2, and here I'm at positive 2. So I have negative 2, 0, 1/3, and 2. What kind of dots do I have at all those spots? I have all open, right? So open, open, open. And now some of you were having questions. You're like, well, wait, how do I do this? Well, remember, guys, all this is just boundary lines, right? I have a boundary line here, here, and here. Pick something to the left of negative 2. Negative 3, okay? If I plug in negative 3 here, does negative 3 work? Is this going to take a second for us to do? Yes, but that's okay. 3 times negative 3 cubed minus negative 3 squared, God bless you, less than 12 times negative 3 minus 4. What is negative 3 cubed? Negative 27 times 3 is negative 81 minus, what's negative 3 squared? 9, right? Less than negative 36 minus 4. Do I have to finish this anymore? Negative 81 minus 9. is negative 90, right? You guys should be able to see right there that negative 90 is less than negative what?
40.
Negative 40. So over here works, is what you just showed me. All right, what's another number I can try?
0.
Let's try 0. If I plug in 0, you can do this in your head. What happens to the left-hand side of your inequality? It becomes 0. And the right-hand side becomes what? Negative 4. Is 0 less than negative 4? No. Okay. So that doesn't work there. Pick a number between 1/3 and 2. 1. Okay, plug in 1. We can do this in our head. 1 cubed is 1, so 3 times 1 is 3. Minus 1 is 2. All right. Then on the other side, I have 12 times 1, 12 minus 4. Is 1 less than 8?
Yes.
Okay, well then this works in here. So let's pick another spot. Let's pick something bigger. Let's pick positive 3. All right, so we're going to do positive 3. 3 times 3 squared minus 3 squared. Is that less than 12 times 3 minus 4? Well, what did we... Oh, this is cubed, right? What did we say 3 cubed was? 27 times 3 was 81 minus 9. Is that less than 36 minus 4? No, it's not. That doesn't work. So do you see the places that this graph, quote unquote, works, or where your values exist? Do you see your graph? Okay, so we should be able now with interval notation to write it. It's negative infinity to what number? Where does your graph stop?
-2.
At negative 2. What kind of a sign or what kind of a notation do I have at negative 2? A parenthesis, good. And then there's a gap, right? Where does it pick up again?
1/3.
To what?
To 2.
To 2. Questions? To me, that would be the hardest problem that you guys would see. Not because it's hard work on your brain, but the computation could get a little yucky.
Why would it be 2? Like after the 1/3, like why would it be 1/3 and then comma 2? Like didn't you say like things after 2 didn't work?
Right, things after 2 didn't work, but it worked up until 2. Yep. Good question, good question. Mm-hmm. Okay, here we go. Look at this one. Oh my gosh, this one looks really crazy hard too. Should we just skip it?
It's not hard.
No, don't write IDK. Come on, you guys can do this. This is a non-linear, meaning there's more than just x to the first power. So everything needs to be moved where? To the left. So I'm going to subtract 4x squared, and I'm going to subtract 15. You guys agree? Okay, when I do that, these cancel out. So what's 6x squared minus 4x squared? 2x squared minus 3x. What's 10 minus 15? Negative 5, greater than or equal to 0. All right, do I have everything on one side, 0 on the other? All right, so what's our little trick? It says greater than or equal to. What kind of dots?
Closed.
Closed. And greater, which way do I go? Now, how do I figure out where I put the points on my graph? I have to factor it. 2 times negative 5 is negative 10. What are the factors of negative 10 that multiply to give me negative 10, but add to give me a negative 3? Tell me. Negative 5 and positive 2. Okay. Now, Kara, what do I have to do? I have to divide both factors by 2 because our A term is not 1. So this becomes 2x minus 5 and x plus 1 equals 0. So now we solve this. When I say 2x minus 5 equals 0, I'm going to add 5 to both sides. So 2x equals 5. Divide both sides by 2, I get x equals 5 over 2, right? And then here, x plus 1 equals 0. I just subtract 1 from both sides, so x equals negative 1. What goes in the middle? 0. Okay, good. What kind of dots do I have at both negative 1 and 5 over 2? Both of them are closed. How come? Because it's or equal to. Good. And which way am I going to shade? Outside. See, it wasn't hard. Don't freak out. The only time they're a little harder is when your exponent is to the third. Now, how do I write this interval notation-wise? Well, wait, let's check. I'm sorry. Let's check 0 in the very beginning. If I plug 0 on the left-hand side, what does the whole left-hand side become?
0.
No. 10. Good. And then if I plug 0 in on the other side, what does the whole right side become? 15. Is 10 greater than or equal to 15? No. So we shaded correctly. So how do I write this? Parenthesis, negative infinity, comma, negative 1, bracket, good, union, bracket 5 over 2, comma, perfect. Good job, guys. Really good job. These are what we did on Tuesday. For those of you who weren't here, there's a video for it. But this is an absolute value inequality. The first thing you need to do is isolate your absolute value. So I'm going to do what? I'm going to subtract 5 from both sides. Now, this is a special case, and the reason I'm starting off with it so you guys can see it. But this is 3x, absolute value of 3x plus 4. What do we know about absolute value of anything? It's always positive. Okay, so absolute value of 3x plus 4 greater than or equal to negative 2. What do you know right now?
It can't equal negative 2.
Not that it can't equal it. It will always be what? It'll always be greater than. Whatever's in that absolute value will always be greater than or equal to negative 2. If you saw that right now, you could tell me your answer is negative infinity to positive infinity. And your number line would be like this, and you would just color in the whole thing. If you don't see that, that is okay. Go through the process that we talked about. Once your absolute value is isolated, then we have our two different inequalities. It's 3x plus 4 is greater than or equal to negative 2. What's the other one? 3x plus 4 is less than or equal to 2. Remember, with our inequalities, you have to flip the sign of the inequality and the answer, because when you change a negative to a positive or vice versa, you're multiplying or dividing by a negative number. So that's why the inequality sign flips. So if we go through this, we subtract 4 from both sides. 3x is greater than or equal to negative 6, right? Divide by 3, you get x is greater than or equal to negative 2, right? And then over here, I'm going to subtract 4. So I have 3x is less than or equal to, God bless you, 2. Divide by 3, and I get x is less than or equal to negative 2/3. Agreed? Okay, so I'm on my number line here. I'm going to say, okay, I have negative 2. I have negative 2/3. And what else do I have to put on there? 0. All right, what kind of dots do I have at both of them?
Open.
They're both closed because it says or equal to. Now think about it. Is my inequality, is my x value on the left-hand side? Is my x on the left? Yes. Okay, that means that you can just read this inequality and you can graph the way the arrow is going. So this is saying I want everything that's greater than 2, or negative 2, I'm sorry. Right? And it's also saying I want everything that is what? Less than negative 2/3. Well, what do you guys notice about that?
They both cross.
They not only do they both cross, but it's the entire number line. It's everything. I want everything that's less than 2, and I want everything that's bigger than negative 2, but I also want everything that's less than, or that's why this is all real numbers. This is your answer here, would be everything that you see.
How did you determine that in the beginning?
Because right here, when we're at this step, do you see how your absolute value is by itself? Right? So anything that is inside of those absolute value bars, no matter what, when you take the absolute value of it, it'll be positive. So this statement is saying that anything here will be bigger than or equal to negative 2, which will always be true. Yes, ma'am. All right, moving along to ones now that are just basic, right? What do we have to do? Before we can split up into two inequalities, what do I have to do? I have to move everything. I got to get the absolute value all by itself, so I'm going to add 4. Remember, SAD, MEP, you do PEMDAS backwards in order to solve or isolate x. So I'm going to add 4, so I have 2 times the absolute value of x minus 1. Greater than or equal to 4 plus 2 is 6. Now what?
I write
divide by 2. So I have the absolute value of x minus 1 is greater than or equal to 3. Are we good? Absolute values by itself? Okay, so let's talk about our sign. What do I notice? It's what? It's greater, and it's or equal to. So I have closed dots, and if it's greater, I go to the outside, opposite sides, okay? So now let's set up our two inequalities. X minus 1 is greater than or equal to 3, or x minus 1 is less than or equal to negative 3. We flip the sign and the inequality sign and the sign of your answer. So add 1, x is greater than or equal to 4, add 1, x is less than or equal to negative 2, correct? So I have negative 2, 0, and 4. Again, what kind of dots did you tell me I have? Closed. And where are we coloring? Outside. So check. What's an easy number to check?
0.
Should 0 work?
No.
Okay, let's plug in 0. What is 0 minus 1? Negative 1. What's the absolute value of negative 1? 1. What's 2 times 1? 2. What's 2 minus 4? Negative 2. Is negative 2 greater than or equal to positive 2? No. So then we're good. So how would I write this? Reese, tell me. I'm going to keep picking on you. Perfect. Negative infinity. Good. Yes, ma'am. 4 to positive infinity. What goes on the negative 2 and the 4? Brackets or parentheses? Why is it a bracket? Because the dot is what? If the dot is closed, that means it includes it. All right, let's look at this one. There's a lot going on, but still, no big deal. Get your absolute value by itself. So the first thing I'm going to do is subtract 3. Good. So I have 2 times the absolute value of 4x minus 1 less than or equal to 6. Now what? Divide by 2. Did I multiply or divide by a negative number?
No.
Multiply or divide by a negative number? No. So this becomes the absolute value of 4x minus 1 is less than or equal to 3. Very good. Okay, so now is my absolute value completely by itself? Yes. So now I can split into my two inequalities. I can say 4x minus 1 is less than or equal to 3. And I can say 4x minus 1 is greater than or equal to negative 3. At this point, guys, once we have our absolute value by itself, I can say, is this less than, greater than? Which way do I shade? What do my dots look like? So it says less than or equal to. So I have closed dots. Which when I think of a closed dot, what kind of a notation do I think of with interval notation? Brackets, good. And less than means I shade in the middle. So I'm going to add 1. 4x is less than or equal to 4. Divide by 4. I get x is less than or equal to 1, right? And then over here, I'm going to add 1. I get 4x is greater than or equal to negative 2. Divide by 4. Am I dividing or multiplying by a negative number? No. Just because my answer is going to be negative, that doesn't matter. But I'm not dividing or multiplying by a negative number, so I get negative 1/2. So on my number line, negative 1/2 is on this side. 0, positive 1. What kind of dots did you tell me I'm going to have? Closed. Very good. And then less than, where do I color? In the middle. So what's an easy number to check? 0. Plug 0 into the originals. Let's do this. Practice this in your head, guys. What's 4 times 0?
0.
Good. Minus 1. Negative 1. The absolute value of negative 1 is? 1. 2 times 1 is?
2.
And 2 plus 3 is? 5. Less than or equal to 9? Yes. So we're good. How do I write my interval notation?
Bracket, negative 1/2, comma 1 bracket.
Perfect. All right, absolute value equations. We don't have to think as much on these ones, meaning we don't have to graph them and we don't have to do our interval notation. So we like these.
What is it called?
These are just equations. See, because it has an equal sign. So again, we're going to follow the same process. We have to isolate our absolute values. So what do I do? First, I'm going to subtract 7. Perfect. So I have negative absolute value of 2x minus 5 equals 20. Then what? Divide by negative 1. So the absolute value of 2x minus 5 equals negative 20. Can the absolute value of anything ever equal a negative number? So right now, you guys would tell me what?
No solution.
No solution. If you went ahead, and I'll post the answers, if you went ahead and didn't realize that, solved it, when you plug it back in, to check it, the equation does not become true. And I will post the answer so you can see it. Yes, ma'am. Yep, because an absolute value, once you have it isolated, whatever is inside of there, absolute value is always positive. So it will never equal a negative number. No problem. All right, let's look at number 8. Isolate first. What do? Divide both sides by 2. So I have the absolute value of 5x minus 1 equals 2. Is that a possibility? Yeah. So now we write two equations. We say 5x minus 1 equals positive 2. And I say 5x minus 1 equals negative 2. Good. This is less steps than our inequalities. So I'm going to add 1 to both sides, and I get 5x equals 3. Divide both sides by 5, and I get x equals what? 3 over 5. On the right-hand side, I'm going to add 1 to both sides. 5x equals negative 1, right? Divide both sides by 5, and I get x equals negative 1/5. What should I do with my answers? You should go back and check. These work. I'm not going to check them right now just because we're a little short on time. But you should go back and check. Is it okay to get a fraction as an answer? Yes. Is it probably going to happen to you tomorrow? Yeah. Probably. So prepare yourself, guys. Don't think, oh my God, you can do it. I have full faith in all of you. All right, this equation is set equal to a negative number. Should I just cross it out and write no solution? No. Why not?
Because we step 6 and you add it.
Window is on it today. You have to first isolate, right? You have to isolate, Reese, you are too. You have to isolate your absolute value, right? Let's get absolute value all by itself first before we say if it's no solution or not. Add 6 to both sides. So I have the absolute value of x minus 6 equals what? 2. Is this a no solution problem? No. So I'm going to separate this. X minus 6 equals positive 2. X minus 6 equals negative 2. Now we solve. Add 6 to both sides. X equals 8. Add 6 to both sides. And x equals what?
4.
Perfect. What should we do with our answers? Go back and check. You guys have 8 questions on your test or quiz tomorrow. Just 8. All right, look at number 10. We see number 10 and we're like, oh, way to go, Mrs. Meadows, right? Why do we hate this problem? Oh, fractions, these darn fractions. All right, well, we're going to think. You guys are going to be okay here. Isolate your absolute value. What do I do now? Subtract the 5. Okay, perfect. Subtract 5. So I have the absolute value of 2/3 x plus 1/2 equals 8. So many of you put 9. 13 minus 5 is 8. Is my absolute value all by itself? Is it set to a negative number? No, so we're good. We can just say, all right, I have 2 different equations. I have 2/3 x plus 1/2 equals 8. And I have 2/3 x plus 1/2 equals negative 8. Good. Now, we're going to do some conversions, and you guys are going to be just fine. I'm going to subtract 1/2 from both sides, correct? Yeah. Guys, if I have the whole number 8 over 1, what is that the same as? It's the same as 16 over 2. So I have 2 over 3x equals, what's 16 minus 1? So 15 over 2. And now we're like, what do I do? How do I get rid of 2/3? I divide both sides by 2/3, right? Well, Samantha said, well, can't you just multiply by the reciprocal? Exactly. If I divide 15 over 2 divided by 2/3. Do you guys remember? Fractions, when we divide, it's keep, change, flip. So you keep 15 over 2, you change to multiplications, you flip 2/3 to 3 over 2. So you just multiply by the reciprocal. Multiply this side by 3 over 2, and multiply this side by 3 over 2. Well, my 3's cancel out, my 2's cancel out. I have x equals, nothing cancels out here, so multiply across. What's 15 times 3? 45 over 2 times 2 is 4. Same thing on this side. Not one part of the college algebra trig is hard for you guys. It's, oh my gosh, I have to get a common denominator and then multiply. Woo, craziness. All right, we're going to subtract 1/2. Again, if I subtract 1/2, how do I change 8, the whole number -8, to something over 2? -16 over 2. Perfect. So if I have -16 minus 1, that gives me -17 over 2. And then how do I get x all by itself? You divide by 2/3, which is really, in a sense, multiplying by the reciprocal times 3 over 2. So x equals, 17 times 3. If you don't know that in your head, which is totally fine, I want to see on your paper 17 times 3. 3 times 7 is 1, right? Carry the 2. 3 times 1 is 3 plus 2 is, so -51 over 4. And what should you do with your answer? You should check it. All right, let's scoot along. I want to do these last two, and then you guys will be done. Okay? Isolate, isolate, isolate. Subtract 5. So the absolute value of 3x plus 4 equals -2. No solution. Why? Yep. Absolute value is always positive, and it's set equal to a negative number. No solution. Move on. I will upload the answers like I just said, and I went ahead and worked it out like pretending you didn't see it. And then when you plug back in, you should see that your answer does not work. All right, last one. Oh, geez. Somebody remind me how to do this. I forget. Tell me. Tell me.
So 4x plus 3 and then equal to the original.
Okay, the original, 4x plus 3 equals 2x minus 5. Agreed. Why can I just do this? Because they both have what? They both have absolute value. They're both by themselves, right? Well, then what's the second one look like? You do the opposite of one of them. I always just do the opposite of the second one. I'm going to write it like this so you guys can see. Because in every other problem, we change the sign of the answer, correct? And it just happened to be a number. Well, in this one, it's an expression. So what you're doing is you're changing the sign of everything behind it. So this is 4x plus 3 equals -2x plus 5. And then now we just solve like a normal problem. We go through the process. I'm going to move numbers to one side, x's to the other. I like x's to be on the left, so I'm just going to move 2x this way. And I'm going to move 3 this way. You guys okay with that? So 4x minus 2x is 2x. My 3's will cancel. 2x's cancel. -5 and a negative, that's a 3. -5 and a -3 gives me a -8. Divide both sides by 2, and I get x equals -4. Is it okay to get a negative as an answer? Yeah. Because you just can't have an absolute value set equal to a negative number, but it's okay to get a negative answer to plug back in for x. Now over here on this side, I'm going to move letters to one side and numbers to the other. So 4 and 2 gives me 6x. My 3's cancel. My 2x's cancel. 5 minus 3 is, right? Divide both sides by 6, and x equals, please don't tell me 3. 1/3. And what should I do with my two answers? I should check them. And when I check them, they both work beautifully. That, ladies and gents, is your quiz. You guys have 8 questions tomorrow. You have some from the first section, solving nonlinear. You have some from the middle section, absolute value inequalities. You have some from this last section, that's absolute value equations. Yes, ma'am.